Hello everyone. Today we're going to look at the derivative as an instantaneous rate of change. So recall from the last section that f prime of x is the instantaneous rate of change of f with respect to x. The one that we're going to use in this section is that s of t instead of f of x is position, or sometimes called displacement, of an object over time t. Then s prime of t is the instantaneous rate of change, but the rate of change of your position is also called velocity. So the derivative of position is velocity. So we're just going to use that. Instead of find the derivative or find the instantaneous rate of change, it's going to say find the velocity. So for our first example, find the velocity of the objects given their displacement functions s of t when t equals 3. So our first s function is s of t equals 4t minus 30. In order to find the velocity, we have to differentiate, and that's going to bring us back to that limit definition, the limit as h goes to 0 of s of t plus h minus s of t. So the only difference is that we're changing the letters. So we need to find s of t plus h. So every t becomes t plus h. Then I'll distribute the 4. And then I want that ratio, that s of t plus h minus s of t over h. Remember, you're subtracting the entire s of t, so don't forget to distribute the negative signs. When we do, the 4t's cancel and the negative 30's cancel, and we're left with 4h over h. Remember, if you're doing this correctly, then everything from your s of t will end up canceling, and everything that you have left will have an h. If it doesn't have an h, then something happened, so go back and double check. So 4h over h, that's 4. And the limit of 4 as h goes to 0 is just 4. So it doesn't matter that t is 3, because 4 is 4 is 4. So s prime of 3 is 4 because s prime of any t is also 4. So let's try another one. S of t equals 120t minus 16 squared. Again, we need s of t plus h. Remember, there are two t's, so make sure both of those t's become t plus h. I'm going to distribute the 120, going to square out t plus h, and then distribute the 16, or the negative 16. Remember, it's a negative. There are no like terms, so that's it. So when I plug it into our fraction, here I've already distributed the negative from my s of t. So negative 120t, 120t cancel, 16t squareds cancel. Again, everything that's left has an h, which means we can divide it. So we get 120 minus 32t minus 16h. And then we want what happens to that as h goes to 0. Again, it's a polynomial, so I can just plug in h as 0, and I get 120 minus 32t. Now remember, we want s prime of 3, so I'm going to plug in 3 for t, and I get 24. The units of this would be whatever the units of the displacement is divided by the units of time. So if position was given in feet and time was given in seconds, s prime of 3 would be feet per second. And here's our last example. S of t equals 3t squared minus 4e. S of t plus h is 3 times t plus h squared minus 4e. Again, when you square out t plus h, don't forget the middle two terms. Multiplying out to 3, and then again there are no like terms to combine at this point. Plug it into the fraction. Distributing the negative, we get this. Again, the 3t squareds cancel, the 4e's cancel. What we're left with, every term has an h. I can cancel it, and I get 6t plus 3h. The derivative is what happens when h goes to 0, so I get 6t. The derivative at 3, I plug in 3 for t, and I get out 18. And again, if the position were given in kilometers and the time was given in hours, then the derivative would be the velocity, which is kilometers per hour. So read through the section, try out the homework, and let me know if you have any questions. Good luck.